which means you can optimize your code better, which means it runs faster because you have better algorithms. You know, when you go to gym and you have a great day and you're working hard and everything's flowing, that's not what counts. So I hope to get those implemented sometime in the near future. So it's an exciting time for D. I also found that D is an easy language for people to learn. People have questions about it naturally, and sometimes things are confusing, but by and large, it seems to be a far easier language. It gave me a lot of confidence that I really could do things and do things that mattered.
Hey, what's going on, folks? It's Mike here, and welcome to a very special 100th episode of the D Programming Language series. In this episode, we have a conversation with the creator of the D Programming Language, Walter Bright. Me and Walter sat down and spent some time talking about his origin story and how he got involved with tech, electronics, all the way through the famous C and C++ compilers that he built up to the development of the D programming language. We'll talk a little bit about the influences in D's design and where the D programming language is heading in the future. It's a very exciting conversation, and I really enjoyed my time talking with Walter. Not only did we talk about tech, but we also talked a little bit about wisdom and persistence as software engineers. So with that said, sit back, relax, and enjoy this conversation with Walter Bright. Ladies and gentlemen, let's go ahead and welcome Walter Bright. This is going to be officially the 100th episode of my D language YouTube episode. So what better way to do it than to have you here, Walter? So thanks so much for joining.
Oh, my pleasure. I enjoy seeing you again.
Yeah. And we have DConf coming up, which we're going to talk about, the annual D conference that's in person in London. But we'll get to that sort of later on in our conversation here, so I hope folks will stay tuned for that. But where I actually want to start this conversation, I mean, we've gotten to know each other a little bit at DConf the last few years now, which has been always amazing, and we have a lot of great conversations that are going to kind of inform a lot of my questions here. But I actually want to rewind a little bit and talk about some of your history, because you've had a prolific programming and engineering career that I want to get into a little bit. And I hope it'll be fun for you to reminisce a little bit, and then also to think about where we are now and where the future's leading. So how's that sound, Walter?
Sounds like fun. Anybody's interested in the olden days.
Yeah, well, I think we can learn a lot, and it's interesting to see how much those skills are still valuable to think about things from sort of the first principles, or how the machine's built even. But I wanted to start with a question about something that I was digging around on your website, and I found a link to Charles Taylor Bright. And I believe this was someone, this was your grandfather or great-grandfather?
My grandfather.
And I recognized a little story about Charles Taylor Bright traveling around the world. Do you know anything about that, or have any recollection or stories about this?
Well, the reason I know about it is he, at every stop, he sent letters home to his mother, who saved all the letters. The letters she wrote him have all disappeared. So, he was a young man. He just left home, and he boarded a yacht by a rich man, and those were steam powered in those days, and he hired on at the lowest, most unskilled position possible, which is the coaler, which means he shovels coal into the boiler, which is a hot, dirty, filthy, unpleasant job. But you could never tell that from reading his letters, because he always had nice things to say. The Slaters, that's their name. The Slaters were the rich people, and the yacht was the Eleanor. So it's fun reading those, because he's a young man who had never left the farm before, and then he travels around the world and writes about his experiences. So I just thought it was a marvelous thing to transcribe all the letters and put them online. And I've gotten a lot of email from people who really enjoyed hearing this story. I'd also like to do with the other side of my family's family letters too, because they're also interesting, but I've never quite got around to it. They were actually very good at preserving their letters, so I have tons and tons of letters from him. My grandfather on the other side of my family was a volcanologist, and he has letters where he was trying to prove the continental drift theory by putting measuring stations up in Iceland in the 1930s. So it's fun reading his letters about that, and his articles he'd write about volcanoes in Europe and things like that. Oh, I'd love to get those transcribed, but yeah.
Yeah, that's very cool. I mean, both of those are sort of, I would say, uncommon in the 30s and even earlier to one, travel around the world or to be doing sort of science at that magnitude. Of course, there's lots of, scientists, but it seems like something that's sort of in your DNA then to explore. And I mean, is that something sort of as a family history of engineers and scientists on one side of the family or other that you have?
Both. I come from, nerds from both ends. So my whole family is a collection of nerds. Unfortunately, I never met either of my grandfathers, which is, both of them are high on my list of, if I could choose anyone to have lunch with, I'd have lunch with them.
Yeah, well, it's amazing to see the stories preserved. I mean, that's something special and even donated to museums so you can at least experience maybe some of the lessons that they have, because that's truly unique, I would say, that the adventures that they've been on.
Mm-hmm.
Both sides. So very cool. I mean, so would you say that, again, with most of those tasks, you'd say determinism or staying focused for long periods of time? Because that's something that, as we get into your career, also seems to be a running theme. Again, are those sort of inherited? Where do those come from? When you were, I don't know, younger or coming up in school, were you able to kind of stay focused on stuff, or how was that?
Oh, well, that's an interesting question. I guess I must have been able to focus because otherwise I would not have gotten anywhere. I've also found what works to me is just dogged persistence. Nearly everything I've tried, my friends, my colleagues, everyone told me that I couldn't do it and I was going to fail. And this is a persistent theme. And then they kind of get annoyed when I actually succeed. So whenever people tell me I can't do something, I take that as a green light. This is the path I need to go. One of the funniest incidents of that was when I decided to write a C compiler. I barely knew C, and a colleague of mine said, "Oh, let's go talk to the local C guru who wasn't working for the company I was, but he knew him as a friend, and he's an expert in C, and we'll, ask him about the feasibility of writing a C compiler." So, we went to meet him, and my friend told him, "Oh, Walter wants to write a C compiler. What do you think?" And the guy looked at me and he said, and I quote, and pardon me for saying this, he says, "Who the do you think you are thinking you can write a C compiler?" Right then and there, I knew what my destiny was. I was going to write a C compiler, and I was going to show him that I could write a C compiler. So that kind of set the course for me. But the thing about writing something like that is most people start a project and it goes along well for a while, and then they sort of, lose interest and drift away. And with me, it's all about persistence. It's not that I work particularly hard or anything. It's just that I just keep working at it. And it's amazing what you can do if you just keep working at it, even as much as, and my motivation comes in waves, usually on a monthly cycle. I don't know why. Maybe it has something to do with the moon or something. But some days I can't, motivate myself to do anything, but I say, well, just 5 minutes. Okay, I'm just going to work for 5 minutes. And so, I get in, I start working for 5 minutes, and sometimes I work for 5 minutes and I leave. And sometimes I sort of get sucked in and I work for 2 or 3 hours and get a lot done. But the amazing thing is, if you don't pick up something every day, you'll stop working on it. So the idea that every day you work, I'm going to work 5 minutes on this. And, you can chop down a tree with a rubber axe if you go whack at it every day. Something's going to happen. That tree's going to fall. So, I follow Arnold Schwarzenegger on Twitter, and he wrote something recently that sort of caught my attention. He says, when you go to gym and you have a great day and you're working hard and everything's flowing, that's not what counts. He says, how you get strong is when you go to the gym, even though you don't want to go to the gym and you hate the idea of going to the gym and you're having a bad day, and you go to the gym anyway, and then you work out. He said, that's when you make progress. That's when you get strong. And that's why I subscribe to Schwarzenegger. If you ever need some motivational things, and he's not somebody you never heard of. He's a guy who's famous for being persistent and being successful because he's persistent. Everybody told him he couldn't make it. He couldn't make it as an actor because of his thick accent, and now his thick accent is his trademark, and everybody loves to imitate it. His accent, it just it's such a great American success story. I love to follow him and read what he writes.
Yeah, he's had quite the career. I think he's a great example, like you said, from acting to getting to all sorts of interesting places at a high level. And I love the story, you talk about. I've heard you talk about the C compiler story and sort of the motivation. It makes it kind of tricky sometimes to figure out who to listen to advice when, you have folks who tell you no, no, no all the time. So, did you have figures or teachers or anything, or just kind of look at examples like Arnold and kind of say, well, I'm just gonna do the 5 minutes, and that was good advice, like little pieces of wisdom like that? Did you have people that kind of urged you on at any point, or
not so much people? The only person in my court really was my dad, and he had no idea what I was doing, but he just liked what I was doing and had fun. But he had lots of books, and I'd go through them and pick out ones to read, and one of them I picked was Reach for the Sky. And it's about Douglas Bader, who was a Royal Air Force Spitfire pilot. And before the war, in a training accident, he crashed and had lost both of his legs. And he was in the hospital, miserable and all that. And somebody came to visit, and the nurse said, "Oh, don't go in there. The young man is dying." He says, "Wait, am I dying? I don't want to die." And that turned his life around, and suddenly he started getting better. And they told him he couldn't dance again. And he said, "Damn it, I'm going to dance with my girl," and he did. And then he wanted to rejoin the Royal Air Force, and they wouldn't let him because he didn't have any legs. And I said, "Well, I can fly." And they said, "No, you can't." And then they ran into this terrible shortage of pilots during the Second World War, and they needed so many pilots, they finally decided to give him a try. So he gets back into the plane. He learns how to fly again with no legs. He had 2 artificial legs. He goes into combat, and he is a very successful, shooting down the German pilots. And then what happens is he gets shot down, and his artificial leg is jammed in the cockpit. And so the only way he was able to get free of his airplane was to unstrap his legs. So, and he parachutes down, and the Germans pick him up, and they imprison him, and he escapes 3 times from the German camps. And finally, the Germans said, "We are very, very sorry, but we just can't have you escaping all the time because it makes us look bad. So we have to take your legs away." So they took his artificial legs away, and so he spent the remainder of the war in the camp, and then he comes back home after the war. His, one of Britain's greatest heroes. And read that book, and you can't help but be inspired by this man, who never took "I can't do something" for an answer. And I'm not comparing myself to him. Okay, he's a great man, and I'm not. But it's that I can do it. I don't care what people think. I can make this happen. And I think too many people kind of get bogged down in people who say they can't do things. People often tell me I'm really smart, but I know what really smart people are like, since I went to Caltech, and I'm not one of them. But what I do have is just simply persistence. If you keep at it, you're going to figure it out, and you're going to make progress. It really isn't that complicated. So those are, I've read other motivational books, but that one was the big one for me.
Yeah, well, some of us in the community might beg to differ, because persistence over time compounds intelligence, I'd say. And I know there's a lot of folks who like to hear your thoughts and understanding on both technology things and compilers and so on, myself being one of them. But like you said, though, I think there is a good lesson here, especially since I teach that persistence and kind of following your path is very, very important. You know yourself best in many cases.
And there's some things I can never be, no matter how much I try. Like I knew from a very early, I could never be an Olympic athlete. I could never be a movie star. I tried playing an instrument. I was a complete failure at playing an instrument, but technology I could do. And I also made sure when I went to college that I took courses that mattered. I never went for the easy A. I always went for the courses I thought would be the most useful in my career. And it turns out I'm not doing anything like what I trained for, but still, having a strong technical education kind of rewires your brain. And when I got my first job at Boeing, I was a green engineer. I'd never done anything, and my lead engineer gives me a job to do, and I was looking at this large blank sheet of paper, and I panicked. So I go back to the engineer. I said, "I have no idea what I'm doing here. I can't do this." And he looks at me and he says, "Sure you can." So the problem was I was assigned the job of deciding the size of the jack screw. And the jack screw is a ball screw about that big in diameter, and it drives the stabilizer up and down on the airplane. And it's a flight critical piece of equipment, meaning that if it broke, everybody's going to die. And, this has happened on other airplanes. And so I was terrified. I don't know what to do. And it finally says, "Well, you know about column buckling from college, right? It says, yeah, I know the formulas for column buckling. And he said, it's a column buckling problem. That just work it from that, you know, the loads and all that. So I went back, and sure enough, and was a column buckling problem. And, you know, I did it. It was like, oh, I know how to do this. So I had a great mentor there, Erwin Schweitzer and Bert Berlin, and they both, you know, whenever I got stuck or something like that, they were just full of, you know, oh, this is no problem. You already know how to do it. Here's how to do it, you know. And so that was a really wonderful experience for me. Well, it gave me a lot of confidence that I really could do things and do things that mattered.
Yeah, what a great teacher, or your mentors rather, and in telling you, you know, what the first 5 minutes of that problem or first steps to take, so you can kind of either reframe it or understand it. And that's everything, right? Even from building a C compiler, right? It's a big task, but what's the first step? And you know, with persistence, like you said, you can figure it out. So maybe we should talk a little bit about some of the first steps, kind of early in your programming career. My understanding is you taught yourself basic programming. Was that the first programming that you had done, or were you working on other electronics or things before that?
My parents gave me a German electronics set, which you know, I played with a lot, and you could build all kinds of circuits with it. And I didn't understand how those circuits worked, and I would just follow the diagrams and things. And since everything was in German, I didn't even understand what the circuits were supposed to do. So I kind of learned to be a very intuitive engineer making these things. And in high school, in my final year there, they offered a course in computer programming. And this was in the 70s. The school had acquired a computer they were going to do. I don't know what they were going to do with. They didn't really know what to do with it. But we weren't allowed to touch the computer because the teacher was afraid we would hack it. Now, I had no idea how to hack anything or how it worked or anything. So how we programmed is we would make these programs on punch cards. Yes, you know, punch cards. We had IBM punch card machines, and we would punch out the thing. And I would write programs that were like 3 or 4 lines long, like to, you know, compute a quadratic equation or something like that. And, you know, that was kind of the extent of it. And then I went to Caltech, and you had free computer time on the PDP-10. So what I did was I started playing computer games. You know, and I'm sure a lot of you out there have had this same thing. You start playing computer games, and it wasn't too long before I got bored with the games and wanted to improve them. So I typed in this program, and you can find it in these old basic 101 basic programs or something called Hammurabi. And so I took that thing and started enhancing it and enhancing it and enhancing it, and it turned into this giant mess. And then I started writing another program called Empire. Empire is a game I invented when I was like 12 years old, but it was impossible to play. And I finally had to put it aside because it couldn't be played. And I was thinking, you know, a computer could actually make that work. And so I spent years working on that, and I overflowed the capacity of the basic programming language. So I had to learn Fortran. So the Fortran version was more successful. The basic version is long gone, lost. But the Fortran version is up on my GitHub account. Sometimes when people resurrect the PDP-10, I send them the Fortran sources, and they try to get that working on their PDP-10. It's kind of fun to see the program has lasted this long. And Fortran on small computers was not a possibility. So my first small computer was a Heathkit H11. And what am I going to do with this? So I decided to rewrite Empire in a similar language on the PDP-11. So that occupied a bunch of time, and I had all these grand visions of selling it, and I finished it and sold 2 copies. So that was my first business failure.
And if I recall, were the Heathkits the machines that you had to also build yourself?
Oh yeah.
To start. So you had to build your own machine and then program it and then try to sell the software then as well. Is that correct?
Right. Well, since I'd played with electronics kits a lot when I was a kid, and my job when I was in college was as an electronics assembly technician. For me, putting a Heathkit together was, Heathkits are real easy to put together, and I hear a lot of people have trouble with them, but all the Heathkits I've built all worked as soon as you turn the power on, because I knew how to build them. So that was fun. It's the only computer I gave away, and I'm just sorry I gave it away. I wish I still had it. Not that it's useful for anything, just if you look at my Twitter profile, there's a picture of a computer on it, and that's my H11 computer. And I was always disappointed that the H11 never caught on as a popular home computer, mainly because DEC was so afraid of it impacting their core business, and their core business got taken away from them anyway. So they could have been at the forefront of the PC revolution if they just simply recognized that it was in their hands. All they had to do was, repackage it, and they could have been what the IBM PC was. And I think it's one of the great tragedies of history that didn't happen. So anyhow, I got a PC, and of course, I wanted to get Empire on it, and then C. I'd never heard of C before, so the same friend who took me to the C Compiler guy gave me a copy of KNR. And a lot of people have trouble reading KNR, but KNR, if you read it, it's exactly like PDP-11 assembly language. The instructions and how they work, even the post-increment and post-decrement, were straight out of the PDP-11 instruction set. And you can tell that C was designed to map directly onto the PDP-11. Mapping it onto the 8086 was another matter entirely, but so I set to work getting Empire to work on the PC, and that's actually sold very well.
So was this, let's see, when you're working on Empire the second time in C, was this still while you were at Caltech, or had you finished your university? Okay.
That was after Boeing, and I was working at Data.io on the Data.io made logic programmers, which were machines that would program programmable logic devices. So you came up with your design, and then you ran it through the ABEL software, which I was on the team that built that, and it would generate a file which you would then download to the programmer, and you would blow a circuit into your PAL or your PLD or your FPGA. So it's really cool that you could get these blank matrices of transistors, and you could burn a circuit into them, whatever you wanted. And this made PLDs very, very popular, because one chip could do thousands and thousands of different things depending on how you programmed it. So those are a lot of fun. So, the C compilers at the time, though, were terrible. And I thought, well, I can do some better compiler than this.
So this was after, I guess, building Empire, going through sort of that process with C and kind of learning from the KNR book. Then you sort of started going into, I think, building your own C compiler, I guess, at this point. Is that the sort of correct history?
That's overall, that's correct. I got into compilers because the compilers were so bad. And I thought, I kept trying to figure out how to make the compiler generate better code, and finally thought I just need to build my own compiler. And the compiler was so bad I knew I could sell it because they were all terrible. After we'd had it for sale for a while, I took a course at Stanford, a summer course on compiler optimizers, and I came back and, that was about data flow optimization. So that really tickled my fancy to make the compiler better. So we did a compiler called the Datalite Optimum C because it had was the first compiler on the PC with data flow analysis. So these magazine reviewer, C Compiler roundups were a popular magazine feature in those days, was doing an article, and they wrote some benchmarks, and they tried the C compilers on them. And they published, without asking me, that the Datalite Optimum C compiler was a completely broken compiler because it generated no code for the benchmarks. And the reason it generated no code for the benchmarks was because the benchmarks didn't do anything. And so the optimizer just deleted it and would only run the printf at the end that said, finished. There were loops like A plus equals 3, A plus equals 3 in a giant loop. Of course, A was never used, so the compiler deleted it and then found the loop was empty and deleted that. And they would look, oh, it deleted. This is a buggy compiler. And I'm still angry about that they'd never asked me about that because they gave us a terrible review. But by the time the next reviews came around, the other C compiler vendors were not foolish, and they all they started implementing data flow analysis ones. So by the time the reviewers get around they all revised their benchmarks to fix it so it wouldn't get deleted by the optimizer. So that was a very frustrating episode for me because how the reviews went really was how the sales went, and we had a big problem after that. It took us a while to overcome.
Did you start getting traction then when at that point, because you had a compiler that was available, and I imagine you had to then, since maybe you didn't get a good review here, talk to colleagues or folks you knew, and that's how folks kind of picked up at the time the Datalite C compiler, or so it was kind of just the old classic knock on a door and ask someone, hey, if you're interested in this better compiler, and kind of have to sell it that way.
We ran print ads in the computer magazines, and those ads worked. Every time a new magazine came out or new issue came out, there was a big surge in sales, which slowly tapered off through the month. It was basically a sawtooth. So we knew the ads worked, and we knew how well they worked and which magazines they worked best in. I tried online ads after the magazines died, and they never worked. I don't know how anybody gets anywhere with online ads because they would not pull at all. The only thing that pulled was writing articles, conferences, videos, all those things, drive interest in the compiler. The ads do nothing. Absolutely nothing. So, yeah.
So my understanding is then after Zortech, there was actually another compiler or a language here, ABEL, the Advanced Boolean Expression Language. How did that...
was the language that was used to program the PLDs at Data.io with. So I wrote that along with several other people for Data.io. And you could say I'd written a Pascal compiler before, but it didn't work. So this was the first working professional compiler, and it made a lot of money for Data.io. So it was very successful until it was finally bought out by another company and went through a few iterations, and then it vanished mainly because nobody used PLDs anymore. Things have gotten much more complicated. They use languages like VHDL, which are much more higher level. So that's what happened to ABEL, and I wish I'd kept a copy of it, but I didn't. So, when you're building something at the time, you never think that somebody might be interested in this 30 years later, and so it disappears. Oh well.
Yeah, we'll see if someone who's listening, maybe they have a copy, or you never know. Folks always pop up with these things, so
it's kind of. I thought I'd lost source code to a couple of programs I wrote long ago, and after my dad died, I was going through his papers and I found a listing of one of my old programs in there. I thought, oh my God, there it is. So that was fun.
I always challenge some of my students to find my old on forums and news groups when I was posting when I was a teenager, and see if they can find me, because I've got code listings and where I was asking for help. It is kind of interesting that some of that stuff does truly stick around, whether in print or online.
This was before the online days, so
yeah,
that's actually even why I had a paper listing. You couldn't debug your code with a 25-line screen. You needed to print it out and lay it out on the floor and go over it that way. So I printed a lot of listings in those days. Now I pretty much never do.
So we're getting closer now to almost to what will be the D language, or what a lot of folks are using now. But in between there's also the Zortech C compiler. So how does that sort of arise after working on Zortech C and ABEL with Pascal? Where does Zortech C come into play?
Well, Zortech bought out the compiler from Daylight, so it became Zortech C, and I was looking for competitive advantage. So I looked at Objective-C and C++, and both of them, the news groups on the internet had about the same volume of traffic on there. So I was thinking, well, which one should I do? And Objective-C was being sold by Stepstone, and they charged a massive license fee, and they wanted royalties and everything like that. And I called up AT&T's lawyer and said, can I make a C++ compiler? Sure. I said, do I have to pay you royalties? He says, nope. I said, do I need a license? He says, nope. I said, well, last question. Can I call it C++, or do I have to name it something else? He says, oh, go ahead and call it C++. And I said, well, why are you being so nice to me? And he laughed and he says, you're the first that bothered to ask. He says, everyone else just copies it and, hopes we won't notice. He said, but we notice. Anyhow. So that was it. I was going to do C++. So I got the C++ reference manual from the bookstore and flipped through it. And I thought, this will take me 3 months. I didn't know it would take me 10 years to implement that blasted language. 3 months, so off and running. And it was Zortech C++. And we were the only native C compiler at the time, and I know this is disputed, but the G++ was out in beta and we were out in an official release, so it depends on how you call it first. But we were the first one on the PC, if you didn't count the Cfront, AT&T C++ translator. But Zortech C++ buried that because it was so much faster, because you didn't have to run it through a very slow C compiler after it. So, and that sparked the C++ revolution, because right then you could see the traffic in the C++ news group just grew exponentially, and the Stepstone Objective-C one kind of faded away until Apple resurrected it years later. So Zortech C++ was making bank then. And Borland was going to invent their own object-oriented extensions to C, but when they saw the success of C++, they threw that away and decided to do C++. And then Microsoft saw how successful Borland was at it and decided they needed to get into C++ too. So if I may be so bold, it was Zortech C++, which created the critical mass that C++ got in order to become, the major systems programming language for years. So I'm taking credit for that.
Well, that's awesome. I mean, can you tell me what was the feeling like in the industry around that time? This would be around the early 80s, I guess, for Zortech C++. Late 80s. Okay.
The early 80s was not C++ at all.
Okay. So there was maybe C++ is still getting research. Bjarne's working on it, but in the late 80s, Zortech C++ comes out. And I mean, that's got to be a pretty exciting time in the software industry because you've got this new compiler, object-oriented programming's maybe getting accepted. There's gaming that's coming up and the graphics are looking better. I mean, what do you sort of recall as far as the energy or excitement around that time? Was it just a really busy time, or what do you recall?
Oh, the excitement was enormous. I mean, as you said, OOP was a big deal, and C++ brought OOP to every computer. Microsoft's COM programming was based on the Zortech C++ compiler because they bought a whole pile of compilers from us. And I heard later that it all went to their COM team. So, the COM stuff all matches up exactly what Zortech C++ did. That was tremendous excitement. And as far as I could tell, about 90% of the programming was in C++ based on, articles in the programming magazines were almost always about C++. And C++ was dominant on the PC, so it was the PC C++, and every once in a while you might read about C++ on the Sun or something, but it was, the PC really was where all the action was. Everything that was happening, people were porting programs from mainframes onto the PC, and it was a very exciting time. It was kind of just before the internet, so we still mailed floppies around. And the software still came in a shrink wrap box. That's all gone now. But yeah, we used to go to the computer store and just browse, looking at the software available and the hardware available. And at the beginning of the month, when the new computer magazines dropped, I was always over at Barnes and Noble, buying the latest magazines to see what's up. And it was a fun time. It was kind of like the early days of flying machines, where once the rights showed you how to do it, everyone was building airplanes, and all kinds of contraptions were made for flying, and there was tremendous advances every year in aviation technology. It was really a fun time, and it was a fun time there too. And yeah, and then Microsoft became kind of the behemoth in the C++ business, and which made things more difficult for us because they had a team of 100 people, and I had a team of 1. And now there were some other people working on other parts of it, but it was difficult. Microsoft was a tough competitor. Is a tough competitor.
Yeah, so Zortech goes from the late 80s into the late 90s or beyond, I guess. What's the sort of time frame?
Zortech was bought by Symantec.
Mm-hmm.
And so Zortech C++ became Symantec C++, and I worked with Symantec on that for a few years. And it was not very successful there. Mainly because Microsoft was just tough competitor. And so Symantec eventually decided to discontinue it. And that's about the time when I left Symantec, and I inquired Symantec if I could buy a license for it. So I basically bought a license back from them and went into business as Digital Mars C++. And sold that for a while, but it was just me against Microsoft. Just wasn't really going to work. So I thought, instead of whining about C++'s shortcomings, which I knew every shortcoming in the language, I thought, the C++ standards committee didn't really pay any attention to things I suggested. So I thought, why am I spending my time with all the politics and C++ and all that instead of implementing? So I just thought, we'll just invent a new programming language based on everything that was wrong with C++ and just do it. And to tell the story again, everyone laughed at me. You can't invent your own programming language. You can't compete with C++. Who do you think you are, thinking you can make a successful third? Well, I found that very motivating. I told my dad. My dad goes, "Great, go for it." Everybody else is, no, it'll never work. So I implemented it, and then somebody released a beta or announced it on slashdot for me, because I didn't want them to, because it wasn't ready yet, and so it became hugely popular on slashdot. I thought, well, I guess I better get it into a working condition, and that's really how D got started.
Yeah, and my understanding was it was originally the Digital Mars compiler,
Right.
as far as the naming, and then did you have a friend or group, or who started calling it D officially?
Everybody did. Like, oh, you're going to outdo C++, the D programming language. And no, it's the Mars programming language. And after a while, you just kind of give up and say, well, everybody's calling it D. Why fight? So it became the D programming language. It was kind of named for me by popular acclaim, and we never looked back. It was just D from then on.
And was Digital Mars or the Digital Mars language because of your love of space and travel and flight, or how did that name come about?
Oh, that's another story. One of my dad's books, and he had literally thousands of books, was called Winged Mars. And the book is a narrative of how the evolution of airplanes influenced the outcome of World War I. And it was the only book I've ever seen which actually equated, whenever the British had ascendancy in aircraft technology, they were winning World War I. And whenever the Germans had the ascendancy in airplane technology, they were winning the war. And nobody else offered that view of things. It was all about the armies moving back and forth. Well, this book there was a rapid evolution in the aviation technology, and both sides were continually coming up with just massive advances that gave them a superiority in the air, and they would drive the enemy back. And the reason that would influence the armies is when you can fly over the enemy lines and see where everything is, you know where to attack. Okay, so the whole point was to prevent the enemy airplanes from flying over the lines, and they did that through air superiority. So, but anyhow, I always liked the name of the book. Digital Mars, that'd be a great name, yeah. So nobody else was using it, so I could in those days, you had to pick a name that you could register the .com name for. So I grabbed that. It was Digital Mars.
Yeah, good name. Good name. So at this point, we've got the D language now officially dubbed, I guess, according to users and the community. And this is part of what folks or others in the D community will call the D1 era, the first compiler. So did that community kind of start growing organically? Folks found about it on news groups or conferences. How did folks start coming to D? Did they just come to the Digital Mars website and download it? Or what do you sort of remember about that, the growth in the early days?
It was the slashdot thing. Slashdot, caused people to come and download it and try it out. And they got excited about it. And the community formed itself. I never made any attempt at organizing a community. It just happened. And people would see gaps in things that were needed and would just do it. And so it, gradually came together via email until one day Brad Roberts said, we need to have a conference. This was in, I think, 2007. And so he got Amazon to donate a conference room for us and just announced the date, and people showed up from all over the world. It was amazing. It was astonishing, and we had a packed schedule of presentations, and there was a lot of excitement in the air. We all knew we were on to something great, and it was wonderful. Brad and I were wondering, is anybody going to show up at all? There was no entry fee. There was no food provided. It was just having the people getting together and having a good time. It was really, fun.
Because at this point, because this is 2007, you've got a conference with your own programming language that no one said that you could build, essentially. Was this sort of achieving your goal at this point for the D language? I mean, did you sort of mark this as success, as I've done it? This was the original goal of D, to sort of take over the world at this scale? Or again, what was the sort of feeling? Was there kind of a feeling of I guess this is complete, I feel good about it, or there's so much more to do now that we have a community? And what was that kind of feeling?
Oh, it was a feeling like, oh my God, we're on to something great, and we've got a lot more work to do. That's what it was. I never recruited anyone to do GDC or LDC. That was just, people just did it. The switch to GitHub, all the other pieces of the tools, the libraries, all grew by people who self-appointed themselves as the czar of this particular thing and just went for it. And I've never been successful at telling people what to do. People always come to me and says, I'm excited about D, I want to work on it. What should I work on? So I list A, B, C, D, E, F, and G, and they start working on Q. It's all people doing, what they want to do with it. And fortunately, we have a wide variety of people that's wound up filling in a lot of the gaps. There's always somebody who wants to work on X or Q or whatever, and we get that done. So actually the stuff nobody wants to do, I wind up doing. So that's a job of John, the CEO, is I do all the work nobody else wants to do. Like nobody else wants to touch the code generator. So,
No, I guess in the early days, as the community is forming, you also get a partner in crime, or another large contributor, Andrei Alexandrescu, who's in the C++ community. I think I know this story because, again, I know some of the history, but how did that come about where you and Andrei sort of meet and start having some chats about what D's future looks like?
Well, I was going to the Northwest C++ monthly meetings, which are still going on, by the way. It's nwcpp.org. And, Andrei was in town, and he would go to those meetings and I'd go to those meetings. So, we'd get to talking. And then he started talking about ways to improve C++. So I told him C++ was never going to implement your ideas. Why not come to D and you can implement your ideas in D? So he said, okay, and joined us. And I told him later that I manipulated him into joining us. I'd read these books on persuasion, and I said, it worked like a charm on you. And he laughed and he said, what did you do? And I says, well, I reoriented my sales pitch to exactly what you wanted to do to C++. You could do to D without having to convince anyone else. And I said, and it worked. But yeah, so that was how I talked him into coming. And then, of course, Andrei became a very influential character. And the funny thing about C++ rejecting my proposals is they've gone on to adopt them anyway.
So I've noticed much of the things coming in the standard library and different safety features and so on are indeed things that D has had for, well, you could count at least a decade in some cases, if not longer, which is quite interesting.
The C++ people generally don't agree they came from D, but it's pretty obvious that they did. So in a way, I was sort of successful with C++ in an unexpected way, that many of my ideas got incorporated into C++, but only after I implemented in D and proved how valuable they were. Then they went into C++.
And I think a lot of other languages as well, when you see some of the, we'll get into some of the maybe technical stuff, but the metaprogramming capabilities in D, for instance, in languages like Zig, and D is directly listed as an influence. So you've influenced quite a lot of the new generation of systems languages that are up and coming in some ways, which has been kind of interesting.
D is still top of the hill with metaprogramming, though. Nobody, I don't know why nobody's actually gone the 9 yards and made it work like D, but D's metaprogramming is really the best metaprogramming system out there. And every new release of C++ gets it a little closer, but they never quite seem to close the gap on it.
Yeah, and prior to this conversation that we're having, I asked the community, the D community, for things that they loved. And one of the top responses is metaprogramming. It's easy to use, and I find metaprogramming in D-Lang quite readable compared to other languages. And again, I can also agree it's leaps and bounds still, where new languages that could study from D still are. So, I mean, why do you think that is? Why can't folks just copy off of D and be at least as good in this, aspect, if they're going to pick, a few things to be really good at?
Well, they seem to, they'll copy features, but they'll miss a salient point in those features that they don't understand as an enabling feature. And one of them was static if. Herb Sutter, myself, and Andrei wrote a proposal to add static if to C++. And it was rejected because static if did not introduce a new scope. And the rejection was all about how it was when you have curly braces, you have to introduce a new scope. And it turns out that, so they finally did, under a different name, implement a static if thing, but it introduced a new scope. And it wasn't long before I realized that you had to have it not introduce a new scope because it became useless. And I don't know if C++ put an enhancement to fix it or not, but to me, that was kind of endemic about how things are copied, as they kind of, and this has happened in other instances, they kind of missed the point of how it worked. And a similar thing happened with ranges. The success of ranges in D wound up in C++, except ranges in C++ are still composed from two iterators, whereas in D, they are one object instead of two objects. And so the problem that C++ has with them is, how do you keep those two iterators together? And it's just more difficult to do in C++ because of that. And they rejected the idea of not using an iterator pair, but making the front and the advance and the empty into one unit. And I was told that recently that an enhancement to C# now follows the way D ranges work instead of their own iteration scheme. So once again, another people finally adopted the D way of doing things. And another thing that, an idea I stole from Ada is putting underscores in the integer literals, which, is a really simple little thing, but it makes it far more readable. And I've noticed that pretty much every language since has adopted that, some mechanism for doing that. And C++ did it a weird way. Instead of using underscore, they used an apostrophe to do it. Not like it just doesn't look right to have the apostrophe, whereas the underscore, works great. So it's just another feature that got copied from D. One feature I've proposed for C that they still haven't copied is putting slices in the language, because using slices ends the problem with array overflows. And you can do it in C and be backwards compatible, because I made a proposal for it many years ago. It turns out in C++, the default arrays still don't check, and even the default way of using vectors doesn't check. And there's a CPPCon talk in 2017 about curiously recurring C++ bugs, and the number one bug is array overflow. In C++, I do not understand why fixing that is not a top priority, because it's always at the top of runtime bugs. And D solved that problem back in 2001, and there it is. It's not patented. You're all free to use it and implement it. I don't get why not. I just don't get it.
Yeah, that's one of those things where I wonder if, well, every language, I suppose, has their trade-offs and legacy that they carry. But as you're sort of thinking about things as a language designer, are you thinking about sort of the safety, the elegance, when you are looking at adding features, such as the underscore between, so you can read numbers and avoid sort of mathematical errors, perhaps. How do you sort of think about the language design? Like, should the language look nice, I guess, and is that a priority?
Oh, well, first I want to say that other languages are free to copy D features. We didn't patent any of them. We don't license any of them. You're free to use it. You don't even have to give us attribution. Just go ahead and use it. It's our technology is our gift to the world. So what is important? I think a huge thing with D is it has to look nice on a piece of paper. There's so many languages I found that look ugly on a piece of paper, and I look at it and go, there's no way I can reformat it so it's pleasing to the eye. And so for me, an enormous consideration is, does it look nice on a piece of paper? And as an example of that, D has bit fields as a preview feature, but it's not a main feature yet, and because some people have some objections to it. But bit fields are extremely useful, and various syntaxes have been proposed in D for bit fields, and nobody can beat the C syntax for simplicity and elegance in bit fields. And I've seen all the other proposals. I've seen the proposals in other languages like in Zig and stuff like that. I always go back to, C nailed the bit field syntax. Nothing else comes close. And even bit fields detractors have conceded that the C syntax is just the best syntax for it. It beats everything else. It's so simple and straightforward. We've fixed things and see that where the syntax was ugly, notably the declaration syntax. So it looks nicer. And we've fallen down a little bit with the attributes because they tend to add a bit of noise to the syntax, and people find that annoying. And I actually agree with them that it doesn't look pretty. I'd like to find a better syntax for that. But in general, the syntax has been very successful, and people like it, and I think it's one of the things that attracts it. Another aspect that people are not initially attracted to D because of, but they become attracted to it, is D is a pretty safe language to write code in. For example, we don't have array overflow bugs. And occasionally I like to look at lists of common bugs in the field in other languages. And I look at the top 10 lists and I go down, and D doesn't have those problems because I looked at those lists and made sure D didn't have those problems. Like in that CPP-Con presentation, another problem people would have is the shadowing of variable declarations and how that would cause lots of bugs in the field. And D doesn't allow shadowing declarations. And so it just hasn't been a problem for us. And nobody really talks about the shadowing issue. It's just one of those things that just works, and people don't even really notice it's there. It just works. The C and C++ have a problem where the extraneous semicolon problem, where you can have a for loop and then the closing parenthesis, you put a semicolon. And I had one guy who came to me and he said, there's a bug in your compiler. I said, why do you say that? He says, well, this for loop doesn't work. I've been struggling with it for all day, and it only executes the loop body one time. There's a bug in your compiler. And I glanced at his code and I says, you've got a semicolon after the closing parenthesis. He looked at me. This was back in Date.io, and so that's why D does not allow a trailing semicolon after these things. And even I make that mistake now and then. I'll put a semicolon in, the guy goes, "Oh, no, you're a naughty boy." C also have, most C and C++ compilers now at least will give you a warning on that. But, why not just fix it, take it out of the language instead of putting a warning? There are also things like the operator precedence. There's some famous problems with operator precedence, and D just doesn't allow that to happen. So those are aesthetically pleasing. Elimination of syntax that's known to cause problems is just make it hard to identify problems with the code. We just eliminated that. So, and the memory safety, of course. And also, we wanted the performance to match C++. So that was a major goal, that it was not a compromise to have these features. If you write the same code in C and in D and C++, you should get the same results in execution speed. And we've been successful at that too. D's never been complained about being short on speed. However, there is one thing that D actually increases the speed over C++ is, and that is the language has turned out to be plastic. What I mean by plastic is it's easy to modify your code. I found with C code that, and in other people's C code, that the first design choice persists until the end of life in it. And the reason it persists is because it's too difficult to change it. For example, in C and C++, try to switch between a reference type and a value type. You have to, exchange all your dots for arrows and all your arrows for dots in 40 or 50,000 lines of code, and it just isn't going to happen. With D, the dot provides both roles because I realize that the compiler can tell whether you mean arrow or dot, so I have the two different syntaxes. And so now you can switch between a reference type and a value type very easily, which means you can optimize your code better, which means it runs faster because you have better algorithms. Another reason why D outperforms them is C and C++ have zero terminated strings, which means every time you need the length, you've got to read the string. Well, D has a pointer length pair for strings, and so your string manipulation becomes easy and far less buggy, because every time I review C code and I'm looking for bugs, I look at the string processing code and I almost always find a bug with the zero termination logic in it. And that problem is just gone in D. And it's faster because you have the length right there. You don't have to compute it every time. So in many cases, D is significantly faster than C and C++.
So a lot of folks ask me, why I teach the D programming language. And many of these reasons that you've listed that I sort of summarize as the defaults are correct in many cases here. Like you said, the no semicolon after a loop, I've run into that. Having all the different warnings that should just be treated as errors anyways. I've run into that from my own experience. I've seen my students run into it. Even simple things like default variable initialization.
Yeah, that one's a big one too.
It's a huge bug and vulnerability, and just one less thing to worry about, and you can get to programming. And like you said, you can get the speed if you do want something uninitialized. So that's always an option.
But
equal void.
You have to work at it. It's not the default. You have to actually say, I want to leave this uninitialized. I remember once having a memory corruption bug, and I spent a week looking for it, and I finally found it, and it was an uninitialized pointer. God. That's when I knew the language had to have default initialization.
Yeah, we learn from our past, or at least in our case, we have with D. So that's a good way to have the language sort of informed by these previous experience.
I do get pushback from it. There was a recent discussion in the news group about why version statements couldn't be used inside enums, and I wrote this, a medium-like thing of why that is, and it's all based on experience with it. And the individuals I corresponded with weren't buying it. Okay. And, I sometimes run into this, and it's hard to say that these things look like great ideas for about 2 or 3 years, but after about 10 years, you realize that they're bad ideas, but I can't really impart 10 years to you. And I really hate saying, trust me, you're going to be sorry using these constructs. And so you're just going to have to trust me on it. And I know it's not convincing. It's tough to do that, but what can you do?
I think it's one of the great challenges, sort of language evolution, and folks understanding that, these features are always, the language is growing. When there are different features like bit fields and so on proposed, and trying to add a feature, as you said, something new, you kind of get one shot usually to add it, and you do want to make sure that it's right, and you want your past experience to be informed by it. Folks can see on the forums or conferences where these discussions are happening, and it is difficult. So, when it comes down to it, do you sort of just decide when it's time to add something? One, of course, there's the experience, but is it better to just not add something if nobody's convinced, or how do you sort of draw the line?
Well, there have been more than one instance when it was me against the world, where everyone disagreed with me. And, at some point, you kind of just got to throw in the towel. If you completely fail to convince anyone, then, maybe you are wrong. And sometimes, I disagreed so much with a feature that it just didn't get added, and just went on without it because I just couldn't bear to put something in the language that I thought was just a bad idea. And, sometimes it makes for controversies, and we've had, as you well know, forums, there have been some major arguments. One of the fun things about DConf, though, is that, I've had disputes with some people for months, and we go to DConf, and, we sit down at a table together with a beer, and all of a sudden the problems just go away and we agree. And it's like, oh my God. So this is why we have DConf. It's not so much the talks. The talks are just kind of the spark. The real DConf is what goes on in between the talks, and that's us getting together and resolving our differences. And that's what makes DConf just essential for the success of D. It's we all get together and have beers together, just sit and talk, sitting in a room, and it's amazing what you can get done, and get our differences ironed out in there. That's the best thing about DConf.
100% agree. Anybody who's listening should consider coming if they're able, or at least watching the talks after, and then getting involved with the community. Because, yeah, like you said, that's the people are the best part, and it's amazing what happens when you get together and discuss all the great ideas that come out. I remember giving my first DConf talk, and folks rose their hand and said, you could improve this, and that. And, all of a sudden my project was many orders of magnitude faster. And so we got some really brilliant people on the the D community who are just freely willing to help and exchange ideas, which is wonderful.
Oh, well, for me, I really miss the camaraderie in the dorms in college, but I kind of got that back at DConf. It's exactly the same feeling. Being around smart, motivated people is just, you know, what do they call it? NOx injection on my engine, you know. Supercharging it, you know. It's just wonderful. You know, just watching a video on your screen is just doesn't do it for me anyway. Being there in person and being able to go up and, you know, shake the guy's hand and then talk, and it just so much better.
Yeah, 100%. 100%. So, you know, thinking about this, because we've got DConf coming up in what'll be mid-September for folks watching this in 2024. What are sort of the next things that folks should be excited about in the D language? Because there is a lot going on in the D community as far as projects, people building things, you know, real multi-million-dollar companies using the D language. What are some things that are on your mind as sort of priorities right now that folks should look forward to in the D language?
Well, two come to mind. Well, three or four come to mind. One is the ARM code generator. And the motivation behind that is the world is shifting away from x86 to ARM. And sort of don't want to get caught with being stuck on the x86. So we're building an ARM code generator, and I know they already exist for GDC and LDC, but DMD doesn't have an ARM code generator, but I'm working on one and it's getting it. Another one is move constructors, which the people coming to D from C++ have a very strong interest and need for move constructors. So that's bubbling up to be a top priority. And a little further down the pike, we have pattern matching and option types, which are also, both of those are a significant advance in programming language technology. And I wish I was smart enough to have thought of them, but, you know, like I said, I'm not that smart. So I hope to get those implemented sometime in the near future. So it's an exciting time for D, bringing all this new stuff online. It's really fun working on the ARM code generator. And, you know, I recently got, you know, Hello World to work, you know, which is, it's alive. You know, I feel like Herr Dr. Victor Frankenstein here. You know, I've got it on this lab and applying the voltage and all that. Of course, I hope things work out better for that than, you know, poor Dr. Frankenstein. So lots of exciting stuff coming up for D. And I'm really looking forward to DConf and seeing everyone there.
Yeah, I can't wait. And I mean, what can we say sort of to folks? I mean, every semester, let me put it this way. Every semester, I introduce a new crop of students, or every other semester, to the D programming language. And it just sort of opens up their world to what programming can be and how exciting and easy. And like you said, you talked about the plasticity of the language and it being nice to sort of read. And, you know, I just see how they think about programming change, which is so exciting for me. And I get more excited. What can we do? Why aren't more people using the D programming language? I guess I should say. That's a
great question. It's one of those, people tend to program with what their buddies are programming with, which is a term called social proof. And it's really tough to break into that. So we could certainly use a better marketing team. We don't actually have a marketing team. Depending on grassroots makes things a little more difficult. We also don't have vast quantities of money to spend on promotion and all that. So anybody wants to help out, if you want to donate vast quantities of money, but things like what you're doing videos. Videos are fantastic for getting the word out and having our presence online. Our presence online could be much larger, or should be much larger than it is. And the way to do that is to write articles and do videos like what you're doing that just show off what D is and what D can do. More.
Yeah, I've always secretly, and I got introduced to the language from Ali Trelli, who gave his talk about D as a competitive advantage. So I have always sort of secretly wondered if the folks who are using it sort of want to keep it quiet because it's an advantage from a sort of software standpoint, and they're not sharing maybe as vocally as they should be. That's sort of been my position, because as soon as I've started coding, I got it, and it made me a better programmer in other languages as well. I could understand metaprogramming only after I did it in D. For instance, just as one example, even some of the functional constructs and so on. So that's my sort of wild theory, I guess.
Oh yeah, I have found when I program in other languages, or when I'm forced to, I program it in a D style now. And of course, it doesn't look as nice and it doesn't have the protections, but it's a more satisfying way to program. I've also found that D is an easy language for people to learn. People have questions about it naturally, and sometimes things are confusing, but by and large, it seems to be a far easier language to learn. To learn C++ takes about 10 years. And it's not just me saying that. The people in C++ say it takes, and even then, do you ever really learn C++? And it's I remember once pointing out a feature of C++, or a detail of it, and Bjarne says, well, it doesn't do that. I said, yeah, it does. It's in this section of the spec. And Bjarne looked at this, oh, I didn't know that. Yeah. So, yeah, it's an easy language to learn. And yes, our major users have told me more than once that D is their secret weapon, because they can get their programs up and running faster. It's quicker to write the code, and the code is more plastic. They can adjust it faster. And, that's what they need, time to market.
Yeah, 100%. So I want to start kind of wrapping us up here, because we're near our time, but I've got a few sort of rapid fire questions for you, maybe, and some thoughts that have come up here. But feel free to take your time with them. But the first one that I wanted to ask you, is this a true or a false story, going back to your Empire classic or Empire game? Were students flunking out of college because they were playing so much?
True story. Also, I'm responsible for at least one divorce, and one person threatened to beat me up because Empire was ruining his life. Because he was playing it obsessively and neglecting his schoolwork.
Too good of a game. And I think I had written to you that I also saw Empire in Sid Meier's memoir itself, which is a really nice antidote and a testament to a well-designed game and piece of software.
Now, if you notice, Empire also has extremely simple rules. There's a common theme there.
I've also noticed a theme with compiler developers and game development. Do those two go hand in hand well? What is it about folks building their own languages and also writing games?
Well, writing games is a gateway drug to programming. And people are always trying to make their games faster. And so I think other people get interested in languages and compilers through the game programming as well. It's not like, I can't really see writing accounting software as, getting you interested in writing compilers or a database thing. But maybe I'm just talking about myself there.
Well, that's my story. Games has always been the gateway. So, and that follows to my sort of next question. Any advice for folks who are learning how to program, where they should start, what they should be doing?
Games. To get an open source existing game that you enjoy playing, open source, so that you can get the source code and then see about improving it. I remember reading the source code to one of the early adventure games called Adventure, or the Colossal Cave Adventure, and I was reading the Fortran source code. And there was a comment in there that really struck me. It said, "A troll is a modified dwarf," in the implementation. And that was my introduction to object-oriented programming back in the 70s. So OOP has been around for a long time, and it was that one line I thought, oh my God, it was like the light went on. This is how you add more characters to the game. You take an existing character and you modify it. Thought had never occurred to me before. So yeah, that book, 101 basic computer games, is games you can just type in. They're less than a page. You can type in and run them and then just start modifying them. It's a lot easier than starting out with a blank sheet of paper. Because then if it doesn't work, you broke it. It's like, oh, you got your troll working. Yay!
Perfect. Maybe that goes with the next question. But the first time you saw something on a computer that made you go, wow, or, this was cool, and a light bulb went off. Do you have a memory?
I think the coolest thing ever I saw was when Doom came out and worked on a PC. Nobody believed such a game was possible on a PC, so nobody implemented it. Well, John Carmack and Romero did the impossible, and it's just world's greatest programmers, because what a feat that was. They did on that primitive machine. They were able to make the graphics like that using every trick known to man. I mean, it's truly an awesome and exciting. I didn't much care for the game. Okay, I played it, sure, but it was their programming that impressed me so much. How amazing.
Still to this day, people read the source code and modify it. So quite an impressive project.
Yep. Yeah, John Carmack and Romero are legends. And I recommend everyone read their biography, Masters of Doom. If you want to be a programmer, read that book. It's like if you want to be a pilot, read Reach for the Sky. But if you want to be a programmer, read Masters of Doom. A great book, great read.
That was going to be my next question, but maybe you'll have another, a book or programming, or maybe a video or something that every programmer should watch. Anything else jump to mind? No,
that one, you can't top that. Though I would say the K&R C manual is right at the top of the list of a book every programmer should read. People say it's difficult, but I remember reading it. It's just like the PDP-11. I hardly had to read the manual. I could program in C.
Yeah, I read it in the mid-2000s, and it still stands up for a book that's 20, 30 plus years old. It still hits right what programming is. So
And the
absolutely.
programming examples in it are complete and simple and easy to understand. A great, although they're not games, you know, there's things like a desk calculator and stuff like that. It's like, oh, that's how you do this stuff. And so it's a wonderful book.
All right. And with that, I'm going to give you the very last word for anything you want to shout out or say as we sort of close off here.
Well, I've been working on D for 25 years now. And I'll be working on it till they carry me out in a box. Nobody's going to cancel this project. You know, I worked at places and they'd cancel the projects I work on, and it's like, I'm not spending my career working on something that gets canceled. I want, if somebody's going to take it behind the woodshed and shoot it, it's going to be me, not somebody else. You know, I worked on the design of the 757, and I always love it when I fly a 757. And whenever I'm in one, I always go to talk to the pilots and ask them how much they like the 757. And they always say, oh, this is the greatest airplane ever. And I say I worked on it. We have a great chat until they, you know, need to get back to work. And the Seattle Times once ran a picture of them scrapping a 757, and they got this giant machine that would cut the plane in half. And I cried when I saw that picture. So anyhow, I'm one of the lucky people to have found a career that suits my personality and is a lot of fun to do and has built a great community around it. I mean, what more could you want? Yeah, it's just you know, I lucked into a wonderful career. And I get to meet all these fantastic, smart people like you. I mean, yeah, Mike, you make it all worthwhile.
Well, thank you so much, Walter. It's been a absolutely wonderful conversation with you. I'm looking forward to more conversations at DConf coming up soon. And we'll touch base there again in person in London.
Okay, it's sure been my pleasure and privilege talking to you and our wonderful audience. Thank you.